Pattern drawing dates back to the earliest move made by man in order to keep records in a coded manner. The hashtag pattern drawn on rocks in South African cave is 73,000 years old. That was in the Stone Age. Pattern drawing has since evolved into quite a number of applications, ranging from baby toys, garment making, storybooks, 2 and 3-dimensional drawings, and even helps coders on their ways to becoming better programmers. In this trading series, I'll use basic Python codes to help beginners sharpen their skills while building exciting patterns which can even be monetized. Hello guys, this is Osichiore from Code with Ozi. Today we're going to be building 3 super awesome cool patterns in Python, and I'm going to be explaining the code. You can see these 3 patterns. We're going to be explaining the code for each of this. At the same time, we'll be drawing them in real. So I already have the code here, but first we're starting with the spirographs, the circle spirograph. So this is my code here. I'm going to delete this. So what we're going to be using in this project, in this tutorial, I'm going to be using a module we call Turtle. Turtle is a Python library used for drawing 2D images, 2D artifacts. So we're going to be using Turtle here. So first, to draw this spirograph, we're going to be import the module Turtle. So don't worry about installing Turtle because Turtle is already a pre-installed library, meaning it's built-in. Immediately you install Python, you see Turtle installed. So after this, we're going to be designing our window for image. You can see the window here. We're going to be designing it. So first we use the Turtle dot bg color, meaning our background color. We set it whatever one we want. So our background color here is black. So we type black. So Turtle is a very easy language because you don't need to put it in RGB format. You can put a lot of colors just in simple string. So after this, we'll set our pen size of our pen we'll be using to draw. We'll set it as 2. So if you see here, pen size width of the side of your pen would be an integer, so we're putting 2. Then we set the speed of what we're drawing, how fast you want the turtle to draw, and also how to explain something to you. This speed now, I set it as 0. You might think that it might make this program run slowly, but instead it makes it faster. The more numbers you put, the slower it works. So put it at 0 right now. Then we put a for loop. You can see there's it's just like a pattern. If you look very closely, you see circles rotating in 360. You see different circles in different formats. So we use range 6. You might think that why range 6? Why not something like range 100? Because the number of squares are many. So we're going to just put range 6. The reason is many, even with this range number, is because we included another for loop. This will contain for color, and we set a list of different colors. We're going to be using red, using magenta. We'll also be using blue and cyan with green. can actually put any color you want. So for now, we'll be using these major colors, yellow and white. So if you look at the code at output here, you can see the format red, magenta, blue, cyan, green, yellow, and white. So it's repeating itself: green, red, magenta, blue, cyan, green, and yellow with white. So it repeats 6 times. So that's why we have a lot of numbers of circles. So we use the total.color method. This method assigns the color, the border color, like the pen color for what we want to draw. So this loop iterates over each of these colors 6 times. 6 times. So we're going to use the total dot color, and we use the color that is present in our for loop currently. And after that, we use the total.circle method. This this circle method uses draws a circle for us. So the most important parameter you must add that is not optional is the radius. We put our radius for our circle. Let's just put it as 100. Then we say total dot right 10 degrees. Then we can hide our total. Let's hide our total for drawing. Then we can run this main loop. So the reason for the main loop, although sometimes people don't use main loop function, the reason for this main loop is to help us see our output before exiting. Before exiting. So without this main loop, immediately the program finishes, the window exits. So let me go back to here. I've not explained this. This right turn is the degrees for where this circle will be placed. So total number of degrees is 360. So we remove 10 each time, draw a circle 10, 10, 10, 10 all around a circle as a circle. So that's why you might think maybe it might stay in the same turn, it adds additionally. Like every time, if it was 10 before, once add 10, it is use plus 10, plus 10, plus 10, and so on. So now we successfully did a program. If we run this, wow, we can see what our program does. It has arranged a spirograph, circle spirograph, and put a design at the middle part. Although this design wasn't created by Total, it was by a drawing. The combination of all these circles can create this drawing. So now we've drawn a circle spirograph. So next we'll be drawing uh, s- um, a square part. Let's see the next one in our drawing. Next we'll draw a square spirograph. So I already have the code here. We delete this. We rewrite it. So actually the code for this is the same logic. We copy this, we paste it here. So it's the same logic with the same colors, but the difference here is you change these parameters to a for loop. This is the for loop we use to draw our square. Square has 4 sides, so it will repeat this code 4 times. We would use the total.forward method, means we'll move our our total from distance forward. But we use the left function, we use the backward, we use the back function, we use backward. So we use forward, we declare the length of our square 100. Then we put the total dot left method means first it moves like here, then moves here, here, here. We're drawing us. Use the left method with degrees 90. So this is the simple code for drawing the square. Then at the end we put total dot left method 12 means it will rotate backward. A square will rotate backward as a circle. So now simply drawn our we've drawn our square pattern, square spirograph. When we run this code, you can see it repeats backward until it completes. So now you can see we've successfully drawn a square spirograph. Although this might look like a circle spirograph because the middle has a circle, but it is a circle because of the combination of squares. Like you can see length 100, this one was connected to another red color here. These both are the same colors, and this one too was connected to this. So it's the combination that arranges this square spirograph. So next we'll be drawing the last pattern. This pattern. This pattern might be difficult to read, but if you look at the logic, it's pretty simple. So we remove this code so I can start writing it again. So we're going to be drawing the geometric pattern. So in this geometric pattern, we import our thorough model. Then we set the background color as black. Then we set our pen size. This time we'll make our pen smaller, we put 1. Next we set our speed. The speed we put it as -10 to make it faster, way faster. Use the dot pen color. We decide our pen color here. So we set it as green for now. Then we declare the length of our pattern. Then we arrange our colors. We set our colors to maybe colors like red, green, um, blue, orange, magenta, and cyan. These are the basic colors we'll be putting. You can put any colors, but for this tutorial we use these colors. So use for I in range 218, 218. So use this 400 this 208 times. Then we use the total.color method. So here we're going to be using our colors into I percentage 6. So we'll be using our number to as an indent. Use this declaration to find out the color randomly, like in the set of out of the set of colors. So then we put the turtle dot forward. We forward it with our length. Then after this, we rotate our turtle backward by 89 degrees. Forward it backward by 89 degrees. Then we can run our main loop function to keep our book. First, I'll show you how it works before without putting the main. You can see our pattern is drawing successfully. We have our pattern prepared. Oh, sorry, it's like there's a little mistake here. Need to check my code again. So maybe we use turtle.colors. So first, wait, let me check the code before I wrote this. So before this, uh, so we're going to check what's happening. We're going to undo everything that happened. Start typing all over again. So you copy from here to here. Then here's we use black. We change the pen size to 1. And we change the speed to -10. And we changed our pen color to green. We'll put our length to be 250. Set the colors as red, green, green, blue, orange, magenta, and cyan. So now we have to change use a while loop. So while the length is greater than 22, let's just use that for example. Then we use this turtle.color method, and we used this declaration colors into I percent of 6. Then we use turtle.forward by the length. Then we use the turtle dot left by 89. Then we can use run our turtle dot main loop. So now we check this program. The I is not defined. Oh, I made a mistake here. We used length instead. So here we can see our pattern. So I think I'm just going to pause the video first and check some